Hi girls, this video is going over quadratic optimization. So what does that mean? Basically, the process of finding a maximum or minimum value of a function is called optimization. So you got to remember, the maximum or minimum of a quadratic or parabola occurs when x equals negative b on 2a. So what am I talking about? Basically, if you have an x and y axis, so here's x, this is y, and let's say you got a parabola. I'm going to go concave down one. Now this point up here is the maximum point, and this occurs when x, so this value of x is negative b on 2a. Now it's important to remember something though. This value corresponds to a y value, and the y value is the maximum value. So the corresponding y value when x equals negative b on 2a, is the max value. So if you want a maximum value, you need to find the y value that corresponds to x equals negative b on 2a. But if you want the maximum point, you have to find the whole coordinate, so the x-coordinate and the y-coordinate. Now this also works for a minimum. So if it's concave up, such as this parabola, in this case, the minimum point, which is here, again corresponds to x equals negative b on 2a. And then the minimum y value would be the corresponding y value for the x equals negative b on 2a. So that's why we're using this idea of x equals negative b on 2a to find the maximum or minimum value of y, or of the quadratic function. Now remember, if a is bigger than 0, there will be a minimum value of y. So remember, when a is bigger than 0, it's concave up. So if a parabola is concave up, then it has a minimum point here, okay, a lowest point. If a is less than 0, it's concave down, which means it'll have a maximum point. Okay, so let's use all that knowledge to do our first problem. It says, find the maximum or the minimum value of y equals 2x squared minus 8x plus 10. So girls, hopefully you realize, here's a, there, the a is 2. Because a is 2, which is bigger than 0, we have a concave up parabola, so like a smiley face. And that means we have a minimum value on a concave up parabola. So therefore, we are finding a minimum value. Okay, so this parabola, this concave up parabola, does not have a maximum value because it goes upwards forever. On these endpoints, it goes upwards forever. So there is no maximum value. We're just finding a minimum value. Okay, now to find the minimum value, we use x equals negative b on 2a. So b from this quadratic is negative 8. And again, a is 2. So we put in negative. Now b is negative 8, so I put in another negative for negative 8 over 2 times a, which is 2. So that becomes, now the negative and the negative make a positive, so that becomes 8 on 4, which is 2. It happens to be 2. That's just a coincidence that it's the same value of a. That's not a pattern that always happens. Okay, now, but here's the thing, they asked for the minimum value. Remember, the minimum value is the lowest point on the graph, or in other words, the y value, so we still need the y value. So y for this value of x. So we sub in this value of x, 2, into the function. So we get 2 times x squared, or in other words 2 squared, minus 8 times 2 plus 10. This here becomes 8 minus 16 plus 10, which is 2. Okay, a lot of 2's here, but it's not a pattern. It just happens to be 2. So therefore, the minimum value equals 2. It's always the y value. The minimum or maximum value is always the y value that corresponds to x equals negative b on 2a. So that's the minimum value, and we're done. Question 2. A farmer has 60 meters of fencing to enclose a rectangular paddock, where one of the longer sides is a brick wall. Okay, so let me just start drawing this. First, we've got to remember that they've got a brick wall, but then the fencing is going to be the other 3 sides. Okay, so all the black has to add up to 60. Now, it says the width of the paddock, remember, width is always one of the shorter lengths, is x meters long. So that means this is x, and also this is x. So now the question is, what's this length here? Well, if all these 3 have to add up to 60, then this red one is going to be 60 minus the other 2 x's, because then they will all add up to 60. Okay? So, or if you like, you can think of it this way. 2x plus the length equals 60. To get length on its own, I minus 2x from both sides. Cancel, cancel. Length equals 60 minus 2x, if that helps. Okay, so now that we've done that, we've got the length and we've got the width is x. Show that the area enclosed is given by this expression here. So now all this working up, I've shown on my diagram and my working down here that I figured out what the width and length is. So area, as we know, is width times length, so it is just x times 60 minus 2x. And that's meters squared. Now, it's important, I can't just go straight to that. Remember, we've got a show word, which means you have to show every step. But I showed how I found the length here. So that's very important. So we've done A already. B, it says find the dimensions of the paddock that gives a maximum area. Dimensions means the length and the width. This means length and width. Okay, but we'll get there in a second. So I want a maximum. They've told me it's a maximum. So let's have a look at that area again. So area is x outside of 60 minus 2x. I better expand that to understand it better. That becomes 60x minus 2x squared. Now, usually our quadratics are of this form. Y equals ax squared plus bx plus c. So let's get them in that order. So we've got negative 2x squared plus 60x, and then there's no c actually. There's no constant. So girls, when does the maximum of this quadratic function happen? Again, as usual, it's when x equals negative b on 2a. So in this case, b is 60. So we got negative 60 on 2 times negative 2. So we get negative 60 on negative 4, which is 15. Now, girls, you might be thinking, oh, don't we want the x squared term to be positive, but there's a negative there. Why don't we move everything to the other side? Girls, this does not equal 0. This is the area. We are not making this equal 0. So it's not like an equation where we can move everything to another side. That's the area expression, and you can't do anything else. You can't rearrange it onto the other side of the equal sign because it's not an equation. So A is negative 2 and B is 60. We can't move it to the other side of anything. So we found the x value that gives a maximum for this quadratic function, or in other words, this area. Now, we don't actually need to find the maximum area. They didn't ask for that. If they did, I would have substituted 15 into this function here, the area. Instead, they just want us to find the dimensions. So what does that mean? Well, the width then, which is just x, would be 15 meters, because that's what x is, 15. The length is 60 minus 2 times x, so it's 60 minus 2 times 15, which is 30 meters. So now we found the width and we found the length that correspond to the maximum area, or the x value that gives the maximum area. And we found the dimensions. That's all they wanted us to find. So now we're done. Okay, so you can see in all these different types of problems, we pretty much always start with x equals negative b on 2a. Then to find the maximum value, we sub it in to the quadratic equation, except, or minimum value. But except in the last one, they actually didn't want us to sub it into the quadratic equation, which again is this one. We had to read the question carefully. They said to find the dimensions. And the dimensions are given by x, 60 minus 2x, and just x. So it's really important that you read everything carefully and you make sure you answer the question as you're being asked to. Okay, now this all corresponds to exercise 1G. Make sure you do some of those questions immediately to make sure that you've understood the concepts presented here.